This is the life cycle of a star, specifically a star 40 times the size of our sun. So, first we start with a nebula. A nebula is a big space cloud of dust and gas. If you look closely, you can see the gas in our nebula. Our star ends up being 40 times the mass of the sun, so our nebula has a lot of materials. Nebulas can be tens of parsecs across, so this one would be massive. This model is definitely not to scale. Over the span of over 10 million years, gravity slowly pulls the nebula together. The nebula then breaks apart into small nebula clumps, all while being under a huge amount of pressure and heating up. So, the gas in the nebula clumps heat up from the amount of pressure placed on them through gravity and create star systems which turn into protostars. Which protostars are basically baby stars. And it's the beginning stage of a star's life. So here we have a protostar, which is the beginning stage of our star's life, which will then turn into a main sequence star, then a red giant star, a super red giant star in our case. So in order to see how it gets to this stage, let's take a look in our core. So as soon as the protostar is formed, nuclear fusion takes place. So nuclear fusion is when a star starts to take lighter elements and fuse them together to make a heavier element. The first element fused together is hydrogen, which is turned into helium. Combining two hydrogen atoms to make a helium atom. When this happens, a massive amount of energy is released. This energy pushes the star outward, expanding it and causing it to increase in size. At the same time, gravity is pushing the star inwards. The opposing forces pushing against each other creates the hydrostatic equilibrium. The stellar standstill within the star. The two forces are constantly in a battle with each other. The nuclear fusion making the star slowly expand, while the gravity is constantly pulling the star inward, trying to collapse it in on itself. When the star is fusing hydrogen atoms into helium, it is considered a main sequence star. So let's take a look at our main sequence star. Our star would be huge, at this point 40 times the mass of our sun. It would also be towards the blue side of the color spectrum because it is hotter than a smaller star. It is expanded outward from the protostar stage because of the nuclear fusion taking place. So it is much larger. Okay. So as soon as you might be wondering what happens after the star runs out of hydrogen to fuse into helium. Well, let's take a look back in our core. Well, it takes helium and fuses it into carbon. And our star has enough mass to continue fusing even that in carbon into other heavier elements. And this cycle of fusing these heavier elements into even heavier ones continues. All the while, the star keeps expanding through the energy from nuclear fusion, continuing to be produced and overpowering gravity enough to slowly expand. As the expansion continues, the star continues to cool down and turns into a redder color since its temperature is decreasing. When the star starts burning its created atoms, so when it starts burning its helium, it enters the next stage of life, the red giant stage. By burning, I mean fusing, by the way. For our star, its mass is so big it becomes a red supergiant. This star is so huge, and it continues expanding until it fuses iron. See, when it fuses iron, something happens. To be exact, this happens. You see, the problem with our star fusing iron is that it takes more energy to fuse iron than the fusion produces. This means as soon as it fuses iron, the energy pushing outward from the nuclear fusion stops and the gravity wins the battle within the star. This causes the star to collapse in on itself and explodes into a supernova in less than a second. This explosion is so powerful, all of the heavier materials are formed at once. So much energy is produced in this explosion that 1 nanosecond of energy from a supernova is equivalent to all of the power plants on Earth operating at full capacity for 2.8 billion years. This puny little explosion I just demonstrated is absolutely nothing compared to a supernova. I'm pretty sure there is no way I could demonstrate a supernova in Minecraft without making my computer blow up. The nuclear explosion of Hiroshima created a pea-sized chunk of uranium. A supernova creates a moon-sized chunk. In simple terms, it's really frickin' powerful. Because of how big our star's mass was, the explosion leaves behind a black hole. A smaller star would leave behind a neutron star. A sun-sized star would not even have a supernova occur, but instead would shrink into a white dwarf star. But our star was massive. Remember, it had 40 times the mass of the sun. So in our case, after the supernova occurs, we are left with what is called a stellar black hole. It appears black because no light is able to escape from it. Gravity is so strong in the black hole that nothing can escape from it, and it is infinitely collapsing in on itself. Because nothing can escape from it, no heat is being released, so it is extremely cold. The ring around it, however, is extremely hot. Along with the black hole that is left behind from the supernova, we are left with a new nebula, which then starts the cycle all over again. This was the life cycle of a star. I hope you enjoyed.